All right, welcome back. Finishing up here on Module 3, Task 4. Let's look at solving an equation now using some of these rules that we talked about with radicals and exponents. Since my last one was radicals, I'll do this one with exponents. And what I'm trying to solve is the equation 9 times x minus 3 squared equal to 4. And using exponents, I think the first thing I would do is I would write this as 9 times x minus 3 squared, but this whole thing I would take to the half, or the square root. Now, if I do that, I also need to do the same thing on the other side, so I'm going to take 4 to the half. Now, square root of 9, or 9 to the half, is equal to 3. X minus 3 quantity squared, the square root of that is x minus 3. And then the square root of 4 is equal to 2. So I can use a little bit of algebra, divide by 3. And I can say that x minus 3 is equal to 2/3. So therefore x equals 3 plus 2/3. So that's one possible solution here. Now, I say 1 because when we take the square root, there's a positive and negative root. So the square root of 9 is not only plus 3, but there's also a minus 3, and that's why there would be two possible solutions that would work here. Okay, and to see these, the next part is a good way to do this. To write a system of equations, and let's do this. Here's our system of equations. One is y is equal to 9 times x minus 3 squared. That's this side. The other, y is equal to 4. That's this side. So if you write an equation for both sides, you're looking for when they're equal because you're solving the system. So for that, we'll go to Desmos. And I've already graphed it here in Desmos. And what you can see, the red represents y equals 9 times x minus 3 squared, vertex form, stretch of 9. And then the horizontal line is the equation y equals 4. And so really, our solution here is the point where they intersect. And you can kind of see it. Let me see here. It's being a little finicky here. Okay, so here's a point. And you can kind of see on that point, the x-intercept is at 3 2/3. So let me put it in point form. 3, and then plus 2 divided by 3. And then this is at 0. Whoops, that's not how I want that. Let's close that. No, we don't want to close it yet. Let's see if we can get a comma in for the y value. And then it should be 0. And then close that, add the label, and 3 plus 2/3. And this is where it intersects with the x-axis. You can see that, so that's the solution to the quadratic. But you can also see, if we say at the point 4, that is where, well, that was the solution we found where the two graphs intersect. Notice there's another one though, okay? This one looks to be like at 2 1/3. So we can write this as 2 plus 1/3. I'm doing that as opposed to a decimal, just because I wanted an exact value. And let me use 4 again. Okay, let me label that also. So you can see there's another possibility at 2 1/3 that would satisfy this equation because it satisfies both expressions. This is the point where 9 times this is equal to 4, these 2 points. So there's actually two solutions here.